Okay, good afternoon. Let's begin today's lesson with our warm-up assignment, page 661, numbers 12, 16, 22, and 30. If you will, please also turn in your homework from yesterday, page 660, number 9 through 31 on. This was from yesterday's lesson on using sum and difference formulas for verifying trig identities. Today's warm-up, same sort of thing. So please, the instructor will pause the video for a moment and you will work on these 4 problems. We'll go over them and then we'll complete section 6.2 today. Okay, let's see how we did on the warm-up assignment. So how do we start this off? Well, what we're going to do is we are going to use our cosine difference formula on this expression right here. Okay, remember this is what we're going to use for angle A, and this 5 pi over 4 is what we're going to use for angle B. So let's proceed and see how that's going to work out. Okay, we now go to our unit circle and evaluate the cosine of 5 pi over 4. Evaluate the sine of 5 pi over 4. Simplify as much as we can. It looks like we can factor out the negative root 2 over 2. And after we do that, we've verified that this identity is correct. Let's look at number 16. Working in angles this time. What if you didn't choose 45 and 30? What if you chose another combination? Would it work? And the answer is yes, it would work. We picked 45 and 30. They're going to be 2 angles in first quadrant. They're going to add up to 75. I really think this is the only combination I can think of off the top of my head, but any combination will work eventually. Okay, on this one, we have to use our tangent formula. Same method, just the tangent formula is just a little bit more tedious in the simplification. Let's evaluate these functions from our unit circle. Simplify. If you notice here, I didn't bother to rationalize the denominator. So if you did, great. But as far as I'm concerned, it's not necessary. Okay, so what are we going to do here? That matches one of our formulas. We just need to pick the correct one, do the math, go to our unit circle, evaluate, and then we're done with our warm-up assignment. Let's go on to today's lecture. Okay, we're going to do more on exact values. And what we're going to do is, this is our typical thing. We're given 2 angles. One is in quadrant 1 and one is in quadrant 2. I don't know what the angles are. None of these ratios are anything on my unit circle. One is going to be angle A, the other one is going to be angle B. And we want to find exact values. Well, how are we going to deal this? Well, what we need to do is we need to deal with the angle in terms of the ratio and not of the radian or degree value. All right, what am I talking about here? And this is what I'm talking about. We need to work in terms of side ratios instead of angles. Okay, let's see what I'm talking about. Look at this little triangle that I drew up here. 12 over 13. Where did I get that from? Well, the sine of alpha is opposite over hypotenuse. So what I need to do is I need to draw a triangle in quadrant 2 with these values. And I need to do the same thing for angle beta. Okay, let's watch carefully what I do here. These triangles here, if you skip this step, you're going to have a tough time. So, let's draw a little angle, a right triangle in quadrant 2. There we go. Where did I get all this information from? Well, the sine of alpha is opposite over hypotenuse. So what I've done is I've drawn a triangle in quadrant 2. Side opposite is 12. The hypotenuse is 13. I can use Pythagorean to find the side adjacent. I'm going to save that for last. I'm not going to do it unless I have to. We're going to see if we have to do it first. Probably will. Okay, I don't know what this angle alpha is. And to be honest with you, we're not going to care, because if it's asked for the sine, cosine, or tangent of angle alpha, I'm going to be able to do it from this triangle. All right, well, what about the angle beta? I have to repeat the process, but this time they tell me this 3/5 is an opposite over a hypotenuse of a triangle drawn in quadrant 1. Okay, again, we can use Pythagorean to fill in the missing values, and that's what we're going to do next. Okay, let's look at angle alpha. By using Pythagorean, we can find the adjacent, and now we know every single thing there is to know about angle alpha. I'm just going to tell you a little hint that's going to keep you out of trouble. All right, I know it's in second quadrant, so the only function that's going to be positive in second quadrant is sine. But if I put that little -5 in there, and I try to get a ratio for the tangent, the cosine, or any other function, with that -5 in there, I'm going to have the right positive or negative value for my ratios. So it's a good thing to include. So when I say 5, I put the -5 in there because that is in second quadrant. All right, first quadrant, I don't have to worry about it. Everything is positive. Okay, so what is it asking for? It's asking for the cosine. It's asking for all the trig functions. There's the cosine of alpha. There's the cosine of beta. If I wanted to, we've done this before, I could find the sine of alpha, I could find the sine of beta, tangent of alpha, tangent of beta. This really isn't anything new. We have done this before in chapter 5. All right, well, what is new? Well, one of the problems, it asks us to find the cosine of alpha plus beta and the sine alpha plus beta. So this is going to bring into our sum and difference formulas into what we're doing here. Okay, there's our sum formula. Now, do I know what the cosine of alpha is? Yes, I do. It's -5/13. Do I know the cosine of beta? Yes, I do. It's 4/5. What about the sine alpha and sine beta? Well, yeah, it was given to me in the problem, or I can just glance up the little triangles that we just got through with. Either way, I can substitute in, and now the rest is just math. I'm going to multiply. This turns out nice. I have a common denominator, and there we go. So the cosine of alpha plus beta, I never know what those angles are, nor do I really care. Okay, I do know that the cosine of those two angles added together using the sum formula will be -56/65. Okay, let's practice this. All right, let's do checkpoint number 5. Let's work this one together. It's going to be similar, but I need to know that you're going to be able to do this on your own. Okay, what are we given? All right, we are given in the problem on page 659, we're told that the cosine of alpha is negative 3/5, and the cosine of beta is a positive 3/2. All right, so I've set up my triangles for each. There's my sum formula. There's my substitution. There's our math, simplification, and we're done. Correct answer. Next part, exact same drill, just different formula. Substitute in the values, do the math, simplify. It's tough to do unless you've drawn those little triangles from your given information. Okay, this is all fine and dandy, but let's not forget our little friend, tangent. Tangent is tedious. It's the same method, it's just after you substitute, the math and the simplification is just quite a bit more tedious. Okay, we're going to plug this into our identity for our tangent. We know alpha is going to be the variable x. Beta is going to be pi over 4. Next step, let's go to our unit circle. Let's find out what tangent of pi over 4 is. It's 1. And then we're done. We've verified that this is indeed correct. Today's assignment. The key part of doing this assignment is I strongly recommend do not skip drawing or sketching a little triangle of your given information. That's really going to help you out a lot. All right, you may collaborate on this assignment and work together, help each other, and get through it. And this will then be checked tomorrow during tomorrow's warm-up assignment. Thank you for your time.